So our aging infrastructure, bridges, roads, that sort of stuff, have been in the news quite a bit over the last decade or so. In particular, things like bridges and overpasses, some of which have collapsed. And of course, if they collapse, if you have some sort of structural failure in an infrastructure, you can kill people. So it's a big issue going on here in the United States in particular. And one problem is with concrete structures as opposed to, let's say, open beam iron and steel structures. And the problem is that it is hard to know what is going on inside behind the concrete as opposed to iron structures where it's visible on the outside. You can kind of see what's going on. All of these structures have some sort of metal behind the concrete, notably steel rebar, which can't be inspected from the outside. And this rebar deteriorates or rusts over time, which then affects, of course, the integrity of the entire structure. So current methods for uncovering this corrosion use microwaves to record changes in the physical state of the affected steel, this rebar, such as changes in the thickness of the rebar within the concrete. Now, according to NIST, the problem with this method, the microwave method, is that by the time these changes are detectable using microwaves, the corrosion process is already well on its way toward causing cracks in the concrete. So, I mean, the barn door is already open, so to speak. Also, according to NIST, most of the microwave imaging methods rely on comparisons with baseline measurements of the steel taken at the time of construction. So they measure the size of the rebar and all that sort of stuff prior to construction. Later on, they use microwave, they measure it internally, and they see how much it's decreased in thickness or whatever. Problem is, this practice only goes back about 25 years. But the average age of the 400,000 steel reinforced concrete bridges in the United States is 50 years. So there's really not a lot of baseline data available for many of them. So this method kind of has some real shortcomings. NIST writes about all this in their article, Move Over Superman. NIST spectral fingerprinting sees through concrete, Superman, to detect early corrosion. So, given the limitations of this microwave inspection, a different method was needed to inspect below the surface of the concrete and detect damage to the steel framework early on. And wouldn't you know, our buddies over at NIST have developed a non-invasive spectral fingerprint technique that reveals the corrosion of concrete encased steel before it can cause any significant degradation of the structure. And it does this by detecting a couple different types of iron corrosion byproducts, which you and I call rust. Yeah, there we go. And it turns out, I didn't know this, there are actually several different types of rust, the chemical makeup of the rust. Yes, it's not just all one rust. You think it's just rust. No,
I had no idea about that. I seriously did not.
Learn something new from NIST every day.
Every day.
Now the thing is, they can use something called terahertz radiation to detect this rust. And terahertz electromagnetic radiation has frequencies that are 10 to 100 times higher than microwave. Now, with the current advances in terahertz sources and detectors, this new NIST, non-destructive technique I should mention, has the potential to quickly detect tiny amounts of these iron-bearing oxides, rust, from early stage corrosion of steel, whether it's surrounded by concrete or polymer composites, paint, any other protective materials. So what they're doing is, rather than, say, actually measuring the thickness of the rebar, by which point, by the time you detect enough of that, it's too late. They're actually seeing, can we detect any corrosion? Then, depending on the amount of corrosion they're detecting, they can make some inferences as to the state of the metal structure behind it. So it's kind of a whole different method of going about this. And it can do this through up to 2 inches of concrete, which fortunately is within the thickness of the concrete covering the first layer of rebar used in most steel reinforced structures. So next up for the NIST team will be an attempt to find a spectral fingerprint for another type. Remember I said there's several types of iron corrosion. There's yet another type that is formed in the presence of chloride ions, sodium chloride, NaCl, salt.
Salt.
There you go. Salt. There we go. And where do we find salt? Well, we find salt near seawater and also where they use road de-icing salt. So this is another, there you go. So this is another important point is now they can detect, or they're working on the method to detect corrosion that is caused by salt. And so the importance of all of this obviously is prioritizing infrastructure project. When you got 400,000 bridges, you can't work on all of them at the same time. So if you can go in early and start detecting structures that may be in a in an early stage of deterioration, or maybe even a late stage of deterioration, you can start prioritizing your projects and know what you got to work on first with a limited budget.
Well, I mean, makes sense, because I mean, you put all that together. I mean, saltwater and salt de-icing,
Right.
older infrastructure. I mean, obviously, the finger is going to point towards the Northeast, where you have the oldest structures, because that's where it was settled.
You're
from.
right, the oldest structure.
The Northeast,
right,
and you have a lot of road de-icing. I know this from
Right.
having grown up in Jersey. That's the way it goes. So I mean, yeah, that's going to be the infrastructure, the bridges in particular, and the overpasses that are going to most be in need of this kind of analysis. And the other thing that strikes me about this is that, as a non-engineer background guy, I'm always interested in how they come to these engineering solutions. It's always a science first. This idea that there's different kinds of rust, which I know.
Who knew? Yeah,
but I mean, that is an indicator of how to create the engineering that will allow you to measure it and get the answer that you need. But the science always comes first, which is it's always interesting to me how that kind of plays out.
And we're going to kind of touch on that a little bit later on as well.
Yeah.
All right.